All right, so remember, we have been talking about absolute value and inequalities. So this says compound inequalities that we're learning this too, but I already taught you that yesterday, or a couple days ago. So I'm going to skip that and I'm going to go down to absolute value. And literally, I'm showing you two problems. So remember, this is a less than problem right here. If it's less than, remember that this is an and problem. Okay, and if it's an and problem, then I'm going to have a graph that looks something like this, correct? Something that's going in the middle of the 2 points. This is an or problem, and that means I'm going to have on a number line, I'm going to have something that looks like this. It's going this way and this way. Sorry, that's really messy. Okay, so what I'm going to do is I'm going to work these problems with you, two problems. So really, I'm not teaching you anything new. We've talked about absolute value equations, and we've talked about inequalities. So I'm going to do one or two problems with you here. Right now, this is by itself. So that means I can write my two inequalities. So I'm going to write 5x plus 2 less than or equal to 17. That is no different than what we've already done. Okay? All right. That is a little hard to read, so I'm going to erase that. Then my second one is the front part is going to stay the same. I have to flip my inequality and change the sign. So I'm going to write off to the side here, flip the inequality, and change sign on the number. So now I'm just going to solve these two little inequalities just like we have in the past. So I'm going to subtract 2, I get 5x is less than or equal to 15. I'm going to divide by 5. I'm going to get x is less than or equal to 3. I'm going to work my second one. I'm going to subtract 2. I get 5x is greater than or equal to negative 19. Divide by 5. I get x is greater than or equal to a negative 19 fifths. All right, so what I'm going to do is I'm going to put negative 19 fifths with a closed dot right here. I'm going to put positive 3 over here with a closed dot. And remember, we know this is an and problem. So then it's everything in the middle. So let's say you forget that it's an and problem, or you don't remember that rule. So then another way you can figure that out is like this. If I do less than 3 and I do greater than negative 19 fifths, what I have in the middle where they cross is my answer. So that's why you have that middle answer. Okay? So let's do another one. Oh, and then let's put this in, I forgot to put it in interval notation. So then bracket negative 19 over 5 and 3 bracket. So let's do the next one. We do the same thing. I take what's in the absolute value, it does not change, and it's greater than or equal to 4. My second equation, the first part stays the same again. Switch my sign, change it to a negative number. add 2 to both sides. I get 2x greater than or equal to 6. I divide by 2. I get x is greater than or equal to 3. So on the second one, I add 2. I get 2x is less than or equal to negative 2. I divide by 2. I get x is less than or equal to negative 1. So now let's put those on a number line. So I have a negative 1, solid dot. At negative 1, it's less than. Solid dot at 3, and it's greater than. Now remember, same thing as I did up at the top with the AND problem, we can do the same thing here. So if I don't remember and I just graph it, this one is not going to change because it goes like this either way. Okay, so on the AND is the only time that you might have, if you do that, it's where they intersect is the answer. And that is all the notes for today.